Hello everyone. Today we're going to be doing a very important lesson. I think it's one that definitely is covered in a lot of different or covered or needed when you go to university. It is the balancing of redox equations using various methods. We're going to start with the oxidation number method, although I really do like the half equation method. So redox reactions are often too complex to balance by inspection, as we did in previous science courses. So in your previous chemistry course, you might have just been able to start with an element and kind of balance it out. There are two methods for balancing oxidation reactions. You can use the oxidation number method, which we're going to do today, or the half reaction method, which we probably won't get to, but I might produce a video on it anyways. Typically, I don't really, if I'm asking you about this, I'm not going to ask which one of the methods you're using. I just want you to be able to do it. So redox reactions transfer electrons from one substance to another. Balancing a redox reaction balances the number of electrons lost and gained, then ensures the reaction obeys the law of conservation of mass. So use the oxidation method to balance the equation below. Step 1, assign oxidation numbers for all chemicals in the equation. So let's go and do that right now. All those oxygens are going to be -2. I'm not even going to think about it right now, unless you've got a peroxide, which we're going to hope we don't, and I'm going to try never to give you one. We've got a 0 for this sulfur. Okay. We know that things like sulfur are very often going to change oxidation states because they have lots of them. Same thing with chromates. Okay, so let's do some math here. We have a -2 times the 7. That gives us -14. We got a +2 from the two chromates, the two potassiums. So how much does chromate have to fill in? What is its missing value here? It is missing a 12, which means dividing by 2, we have +6 for chromium. And then over here on the sulfur side, we have -4 here. So the sulfur here has to be +4. And the chromate over here is -2 times 3. That's going to be -6. So we need a +6, which means the chromium is only +3 on this side. So these are the two that are going to be important to us, is the sulfur and chromium. Starting to regret that 0. I didn't draw very nicely. Okay. Identify the atoms or ions that are oxidized and reduced by examining if there is a change in the oxidation number. Make sure these elements are balanced using coefficients. Okay, so we want to balance the chromate first. We see that the chromate, there are 2 of them and 2 of them. Okay, so that's balanced. And we want to balance the sulfur. So far the sulfur is balanced as well. But now it says balance the electrons lost and gained. Make the change in oxidation number equal in magnitude by adjusting the coefficients in the equation. Okay, so let's look here. We've got the chromium, right, goes from 6 to 3. So we have Cr plus 6 going to Cr plus 3. And we have over here the sulfur is going from 0 to sulfur plus 4. So that means that the sulfur plus 4 is getting 4 electrons, is producing 4 electrons, and the chromium is absorbing 3 electrons, each chromium. So what is this? What are we going to think about here? We've got a total of, right now, without doing anything, we actually, because of this 2 down here, we actually have, we're going to have 6 electrons, right? So maybe we should expand this a little bit and say, hey, we're talking about K2Cr2O7 plus 6 electrons to give us those 2, the 2 in the Cr2O3. The sulfur one doesn't matter so much. Okay, so 6 and 4, we need to think about what is the lowest common denominator here for that 6 and 4 electrons. So we actually are going to have to go quite high, right? Because if we double the 6, that will be 12 electrons. So if we put a 2 here, then that's going to be another 12, and a 2 there. And then that means that we would have to go 3 so that we end up with 12. Okay, so that's what I mean by balancing the electrons. We have 12 electrons in, 12 electrons out. So that's going to be a big part of our balancing part. So we're starting to write our balanced equation now. 2K2 Cr2O7 plus, and we leave some room for my H2O because I might need to do something with that. And then 3 sulfurs gives me 3, because those ones were already balanced, 3SO2 plus, and then we're going to have a KOH, and we don't know what we're going to do with that yet, and then plus the 2 Cr2O3. Now, those are all balanced, so hopefully we should be able to balance everything else. If necessary, use conventional method to balance the remaining of the equation. So these ones are locked in. Once you've made sure the electron numbers are balanced, they're locked in. They all have to change together if you have to change them at all. But that shouldn't happen. So now it's just a matter of checking out some of the other details, see if you need extra of anything. So for example, I know right away that I have a problem with potassium because I have over here 4 potassiums and only 1. So I'm going to go in and I'm going to put in a 4 right here. See what happens. Okay, 4 potassiums. That gives me 4 hydrogens here. But I've only got 2 hydrogens over here, so I'm going to put a 2 there for hydrogen. And now I'm going to count up the oxygen and hope I worked everything out. So 2 times 7 is 14. 14 plus 2 times 0 is 16. So that's 16 oxygens on that side. And then 3 times 2 is 6. So that's 6 oxygens plus 4 times 1. So 4 oxygens times 1 plus 6. It's 10 oxygens. And 2 times 3, that's 16 oxygens. So that looks pretty good to me. We already know the sulfurs are balanced. We already know the chromates are balanced because we did that balancing earlier. So that's the balanced equation. And that might have been very difficult to work out because it might have been easier to balance them just by the elements first, but you might not have realized that you weren't balancing the electrons. Okay, so let's try this one here. So step 1 of sign oxidation states, 1, 0, minus 2, plus 1, plus 1, minus 2. I'm just doing the easy ones first. Plus 1, minus 2. Okay, now I'm going to zoom in on each of these. So HNO3, minus 2 times 3, minus 6, plus 1 for hydrogen. That means I need a plus 5 to fill in the gap. So plus 5. Okay, over here I got a minus 2. I needed to add up to 0, so I need that plus 2. Plus 2 for nitrogen. I got a minus 2 on oxygen, so that's going to be minus 8 for all 4 of them. Plus 1 from hydrogen, plus 3. What's missing is, to add up to 0, I need a plus 5. Okay, put that 5 in. All right, so now we need to double check that the elements being oxidized and reduced are balanced with each other. So we have a 0 phosphorus, which goes to this H3PO4, and that one's plus 5. So right now, element-wise, they're balanced, and we can think that this is producing 5 electrons. And then the other element, the other chemical, is this HNO3, and it's going to NO, and we're going from plus 5 to plus 2. So that means that I'm adding 3 electrons. Okay, so to balance them out, I'm going to try to balance out this value here first, right? So how can I make 5 and 3 equal? I'm going to multiply them by 3 on this side. So 3 times 3. That gives me 15. And if I multiply by 5 for this one, I'm going to get 15 and 5. So there's my first numbers. So that gives me a 3 in front. It gives me a 5 here, and a 5 and a 3. And now we just have to figure out the hydrogens deal. So let's see, I have 5 HNO3s. So that means I have 5 hydrogens plus, or you know what, let's figure out on the right first because it's easier on the right. So 3 times 3 that gives me 9 hydrogens. Okay, 9 hydrogens. Over here I have 5 hydrogens. So if I put a 2 here, then this would be 4 hydrogens plus the 5. That would be 9. Okay, so there's my 9 hydrogens. Let's see if the oxygens worked out. 5 times 3 is 15. And 2 times 1 is 15 plus 2. So 17. I have 17 oxygens on this side. 17 oxygens. And so let's go on the other side. 5 times 1 is 5. 3 times 4 is 12. 12 plus 5 is 17. So I have 17 oxygens. So it is balanced. So whatever we had, 17 oxygens and 9 hydrogens. 17 oxygens, 9 hydrogens. And we know the phosphorus, we know the nitrogens are balanced because we balanced them ahead of time. So that's our final balance. Okay, let's look at this one. So this one looks like it should be really straightforward, right? But we do still want to take our steps and go through them. So copper is a metal, and it's by itself, so 0. Chlorine is a element, also 0. Copper here is +1, so that means it's +1. And chlorine is -1, so that's -1. Looks pretty good. Hey, pretty balanced. Except it's not, right? So now the first thing to do is to make sure the elements that are being oxidized and reduced are balanced. Copper goes to copper, that's 1 to 1, that's fine. But then this one goes 2 to 1, and so that means I need a 2. So I need to put a 2 there. Okay, so then that means that if I'm going chlorine 2, going to Cl, 2 of these Cl minuses. So I needed to add 2 electrons to make that balanced. Down in the copper section, I have 1 copper going to copper plus, and that means that I must add 1 electron. So then to balance the total number of electrons being donated and moved, I'm just going to double this copper to get my 2 electrons so that it's equal to the other 2 electrons. Put that 2 in front, and then let's count everything up. 2 coppers, 2 coppers, 2 chlorines, 2 chlorines, all done. Okay, so there is the balancing of that, and hopefully that goes okay for you. I actually do really like the method where you use the ionic equations using half reactions. But I think that process we are not going to get into this year. It's late enough in the year, and so we are going to end right here. Hope you've enjoyed the course, and best of luck to you in your future studies. And we will discuss more in the next time we talk to you. Not in the next lesson. All right, have yourself a great day.